if we turn around and look at our models that we've created this time. So again, when we're looking at our models, we want to think of the components that you guys included, the relationships that are shown between those components, and then how well that explains what we observed. Right? So models always have to connect to the phenomenon. So let's go back. What did we observe? So with the Van de Graaff machine, like second week of school, what were the observations with the Van de Graaff machine specifically? So I piled the pie pans on top of the Van de Graaff. What happened? Kinsey, what did we see? Yeah. They just like slide off the sides? They flew off? Okay. Anyone want to add anything to that? Yeah, Jake?
I think that the shape of the pie pans could have had an effect on their path of travel. Because if they were just flat sitting on top, they just kind of went like this and slid off. But since they were curved, they went more up.
Up? Okay. All right. So at first they were like sitting on top and balancing there because of the shape of them. And then when we turned it on, they flew up and then fell as opposed to just sliding off. Is that what you're saying? Okay. All right. So if we look across our models, and don't miss these two over here, any common components, any things you guys notice?
I see a lot of Van de Graaff.
All right, a lot of Van de Graaffs and pie pans. Any other components in common?
A lot of before positive.
All right, positive charges. Arrows to show the relationships. Words. Do we know the Van de Graaff is positive?
Yeah.
All right, so Blake, what evidence did we have that the Van de Graaff is positive?
You said that.
Yeah, Ryan?
I believe the same under a rig, but also, it showed in the observation since the pie pan flew off that it would have ripped out, so it had the opposite charges to show that they had different charges, so it wasn't a positive anyway.
So the pie pans are the same charges as the Van de Graaff or opposite charges?
Opposite.
So opposite charges do what?
They
This is a discussion about a topic this class has been studying for a while. The goal of this discussion was to develop a consensus about what was happening in the phenomenon. However, I still want students to be basing their answers on the evidence they have collected, not my reactions, so I still try to respond neutrally and ask for additional input or alternative ideas from students. Since we were building a consensus, when a student made an inaccurate statement, I asked some follow-up questions to see if he misspoke or was confused. When he realized his mistake, I pushed him to restate his answer to make sure we were on the same page. If it had been a discussion of initial ideas, I would not have pushed him to correct his answer, but instead pointed out the different thoughts students have about the interaction. In this discussion, I did ask quite a few questions that had straightforward and simple answers. Normally, I would try to ask more how and why level questions, but the students were being unusually quiet. So I made the decision to switch over to simpler questions that had more straightforward answers as a way to get the discussion started. Then, once students were talking, we could transition into deeper level questions.